What's up, you guys? Matthew here. In this video, I want to walk you guys through my opinion on when I think agents are actually necessary compared to when they're just a novelty. So I want to walk you guys through my journey in learning how to build agents. I've built a few different agents for different purposes, trading, whatever, research. And basically, this is how I got started. I watched this video on the LangChain channel, building effective agents with LangGraph. We're not going to watch this whole video in this video, but we're just going to stay paused on this snapshot because this slide here captures everything I want to talk about. But definitely watch the video. It's a video that was inspired by a blog post that was written by Anthropic, and basically the people who built and invented these agents told people about these different workflows and basically the definition of an agent. And so that's what I'm going to go through in this video and then give my further opinion on when I think they're necessary. So to get started, what is an agent? To me, an agent is a language model that can access tools. But what that means is that it's a language model that's good at doing that. So some language models are better than others at accessing tools. And that's basically because when it's accessing tools, what it's doing is, as a language model, it's generating a response, because that's what they do. They just generate response. It generates an output that happens to match the schema of a tool request. So if you want to use a tool, usually you have to put in a request to an API, and the API request looks like a specific format that basically is a schema that can be a JSON output. It can be basically a formatted output from an LLM that represents the input for a tool request. And so those outputs need to match the actual format and the syntax. So therefore, some language models are better at doing that, and others are not good at doing that. And so the ones that are better at doing that are better at being agents. So it's good to understand what fundamentally an agent is and what makes an agent or a language model good at being an agent. And so that's what it is. And basically what a harness is, these different frameworks that go around a language model to make it more agentic. What they are is basically like a package of adapters that go in between the language model and the tool requests. Adapters such as different mechanisms to make things go smoother and more reliably. For example, you might want to make a tool request, and let's say your language model messes up and the schema that it outputs doesn't actually match the syntax that is required for the tool request. Then in that case, you might have a harness with a retry mechanism that has a more elegant way of retrying, where it tries to repair the syntax before it actually does a full retry, and it has these different thresholds. And basically, when you have a bunch of those types of adapters for a bunch of different things, then you have a reliable harness, a framework that the agent can basically go in and use as adapters for all of these tools to become like a fully fledged, reliable agent that can use this tool, that tool, and it doesn't mess up. It does so reliably. And reliably is the key word, because these are language models. Reliably, what you're trying to solve for when you're making it reliable is basically the fact that an agent is probabilistic. It's not deterministic. And so because you're dealing with something that has varied response, you want to kind of rein it in, give it a harness so that these responses aren't drifting from the intended output and structure. So in order to do that, sometimes you need to kind of babysit the outputs. And that's what a harness does. It basically turns an unreliable language model that's probabilistic into a reliable tool mechanism that can use things almost as reliably as when you try and basically build a deterministic script that's written in some sort of scripting language, coding language. And so the difference there is that you get these benefits from using an agent, whereas you get benefits from using a deterministic script. And so there's kind of like a give and take. There's pros and cons from those two different setups. And so it matters. It matters that an agent can't do deterministic things as well as just basic scripts, because if you're using an agent as a novelty to automate something that can just as easily be automated with a deterministic script, and it's repetitive, it doesn't, it's not an open-ended workflow. An agent, given that it's an LLM with tools, what makes it necessary is when you use that within a workflow that is open-ended. That is when you have an intended result that you don't necessarily know the steps that are required to get there. And so you can set up an agent, you know what you want, so you set the intention and you provide the agent with the intention, and it chips away at these unknown steps to get to the intended result. And so agents are results driven. They understand completeness, done, correct, finished. They understand metrics like that. And so as long as you give it this reliable, these reliable rails to converge on your definition of complete, that's what an agent is for. Whereas if you understand all of the steps, you just write a script and it can do that. So there are different ways to use agents. It's not always just an open-ended workflow. Sometimes you can have an open-ended workflow that is contained within a deterministic workflow, and that kind of becomes an orchestration. And so this slide here from the Building Effective Agents video is kind of like everything that you need to know, and when to build just a simple prompt chain, when to build a full orchestration, or when to actually have an agent that doesn't exist within a strict framework. It's more or less just an open-ended agent that kind of does things more autonomously, and you're kind of trying to hope that it spins up its world model in a way that is effective for your intended outcome. So it kind of like starting its journey is like, I want to get this goal. The language model has to kind of understand all of the different aspects of your intention and then arrive there. That is pretty open-ended. So that, to me, sometimes people use that as a replacement for process. So it's kind of like admitting you don't know what you're doing. It's kind of like making an agent workflow, which is nice and everything. But if you're not bringing your domain expertise to a workflow, then you're just replacing lack of process with more vagueness. So the agent's probably not going to do a better job than you. Unless you are a domain expert, then you probably can't build an effective agent. So that's kind of what I'm saying there. Now let's walk through these, go from A to B, and then I'll just kind of end the video because I don't want to make this too long. It's already 7 minutes. So what's a prompt chain? Basically, it's just an LLM call where you make a request to an LLM within a script and you use the output from that request. So you request the LLM, it gives you an output. Now you use that output as the input for the next request to another LLM. So that's a prompt chain. If you want to do two requests at the same time that don't require the output from another to use as the input for the next, then you can just do them at the same time. That's called parallelization. An orchestration is when you can have an agent that is an open-ended workflow, but the open-ended workflow exists within a prompt chain that is more or less deterministic. So you can do, say, like a prompt chain that contains parallelization. You could do a prompt chain that contains orchestration, and in the orchestration contains an open-ended workflow that eventually closes out and goes back onto the chain. And so there are these different mechanisms. Routing is another good one. It's if you have these different deterministic mechanisms for classifying. Classification is one of the best things that LLMs can do, given its ability to interpret context, and therefore it has an increased capacity to classify things as a language model. So it can categorize things easily. So you can have a router that uses a classifier that then puts something on, say, a different prompt chain. So then it gets routed, then it's on one chain. Maybe a chain contains a workflow that contains an open-ended workflow, right? So all of these things can be used together. And there are other videos. Obviously, this guy has like 20 different agentic designs. It's just basically different hierarchies and different ways of structuring. And so a lot of this can be done just in raw code. So this is a Python script that I wrote for a prompt chain that contains routing. It has like a route for utility. This is basically what it is. It's a workflow for doing research and searching on social media, a bunch of details for these tokens on Solana. And so what I'm doing here is I'm creating a Python script that is a prompt chain that has a router where it can classify something as a utility token or a meme token. And then it has deterministic routing that sends based on these classifications that I get from an LLM as the first prompt. It says, here's the description, classify it. Here's the image, classify it. Here's all the context, categorize it. Given the category, put it on a specific prompt chain where it's going to search the documentation of its utility, or it's going to search the memetics and kind of like the history and, or lore of the meme, if it's a meme and stuff like that. And so you get a workflow that is basically a chain of prompts written in Python. Now get this, I have no harness. I did not write a harness. This is a raw agentic workflow that uses a prompt chain, it uses orchestration. It has some open-ended within the orchestration. The open-ended part are the, I call these agents compound mini. In the script, I'm calling compound mini. You can see it up here. Right here, I'm calling compound mini as my agentic model for web search. And so within the web search, it has some autonomy, and I'm trying to rein it in. If I'm going to my web search prompt here, I'm not sure if this is the web search prompt, but you can see the prompts written in plain language here. And when I'm using these prompts, it's more or less telling the language model what to output and what to generate. And when I'm doing the web search, if I can find it, what it's doing is it's basically trying to research all of the context, building a narrative rubric. I can't find my web search thing. That's the one fallback of generating code with AI, is you don't really know what you're looking at. This is the sentiment score. So you can see I'm doing a bunch of stuff in Python here. And I think the benefit of having Python do this deterministically is that you get a lot of control over the prompt. You get a lot of control over everything. And so you're not just dealing within one specific format. Anything's possible. It's like your canvas. And so that's how I like to build workflows. I like to build them in Python. And I don't even use a harness, because sometimes things are simple enough that the reliability is there regardless, because the model is good enough for the simple thing that you want it to output. So if I wanted to have a more expensive setup, I could use a better model, full-blown harness. But then sometimes with the harness, you're stuck there using expensive API keys. Now you're dealing with a situation where you're just basically killing a fly with a sledgehammer. It doesn't make any sense. So I use a lot of low-tier models, such as Llama. Quen is like a GPT-4 level model. Compound Mini leverages like a GPT-4 model. So these aren't frontier models that I'm using within my workflows, because I'm trying to min-max. I'm trying to get the models that can generate reliable outputs for the lowest cost and yet still be reliable, because you get diminishing returns. If I want to use like Sonnet 4.5 for everything, or Opus 4.6 for everything, then it's like renting a Lamborghini to go to the grocery store. It doesn't make any sense. So you want to use the lowest model possible. You want to only use agents, because those calls are actually very expensive. You want to only use them when you actually have an open-ended workflow. If you have an open-ended workflow and it's just a replacement for lack of domain expertise, then you're just kind of like creating slop. So those are my full opinions on agents. I think what an LLM is best at, its like most core unique use cases are context engineering, interpretation, classification, things that require a language model that older methods just simply can't do. And what a language model is best at are those things. It's interpretation, contextualization. Interpretation and contextualization are so big because they unlock a different form of classification that was otherwise impossible. So basically what you're doing when you're building an agent, for the most part, most of the time, in my opinion, is you're just using the interpretive contextualizing abilities to classify things, to route things, so that you can then use other deterministic workflows after the classification. So that's like the most core thing that a language model is useful for, like actually. So that's what I would actually build if I were you. And that's what I built. So The only time I actually use a language model is when I need to interpret something or contextualize something that can't be interpreted or contextualized by like a regular Python script with like regex or some sort of heuristic for classifying. If any other heuristic for classifying is effective enough, then I'd still don't even use a language model. But if all other heuristics fail and the only heuristic left is a language model being able to interpret and contextualize, then I use language model. So only use it for what it's necessary for and when it's actually needed, and then you'll be min-maxing. You're actually going to get the best results and the most efficiency. You're not going to be renting a Lamborghini to drive to the grocery store. All right, so that's my full take on agents. I'll see you guys in the next video. Maybe we'll go through better stuff regarding actually building an agent or different harnesses and stuff like that.